Good morning and welcome to our session on Apache NiFi. So today we'll be looking into what Apache NiFi is, and we'll be going over some of the very fundamentals of Apache NiFi and what problems it solves. So this is not a detailed NiFi session. It's more of an introduction. So before we get started, let me be sure that I'm audible and clear. Okay, great. So let me tell you a bit about myself. My name is Gurmukh Singh, known by the nickname Aman. I've been in this industry for more than 16 years now, mainly into systems engineering and platform and data engineering. So I've been in Hadoop or big data, you can say, which was coined much later for the last 9 years. And I've been doing a lot of trainings in big data DevOps space and have developed content for a lot of the training providers from 2012. For the last few years, I've not been involved actively in meetups and trainings. So I thought, okay, let's get together again and start the meetup. Also an author on a few of the books, which is Hadoop Monitoring, Hadoop Administration Cookbook, and also have a GitHub and a YouTube channel, which you guys can have a look at. So I upload a lot of videos there, which is kind of snippets from my courses. So you can go through it and have a look over it. Okay, let me show you my GitHub. So this is the GitHub which I've been maintaining for quite few years now. So I started with this around 2011-12. So it has two branches. One is the master branch, which is talking about Hadoop 2 and Hadoop 3, right? So, and also you can look at the courses offered. So which has been I've not updated it for the last 2 years, but yes, if somebody is interested, we can look into it and kind of customize any of your training requirements if need be. But yeah, so these are the training links I have there, and there are a few others as well, like NiFi, Airflow, Spark, right? But if need be for anything specific, we can look into it. And here, if you look here, these are all the configs which talk about Hadoop 2 and Hadoop 3. And if you look into my old branch, which is Hadoop 1, which is obsolete now, so you can look at 7 years back I started all these things, and a lot of people have been following it, and a lot of content providers based in India have been for referring this, because as I said, I developed content for a lot of the online training providers, right? So which was mainly into Hadoop and DevOps at that time. So feel free to use this GitHub. It is quite useful, talking about the manual way of doing things, right? Going editing each and every config and modifying it. Now let's look at Apache NiFi, right? So let's get started and quickly look into it, what it is, right? And as I mentioned, I encourage you to have a look at my YouTube channel, where I've uploaded Linux fundamental courses as well, which are kind of important for anybody who is not from a Linux background and is planning to learn Hadoop. So I've run through some of the very fundamentals of Linux. Let's say how we install, what are the file systems, what are the commands you need, all those kind of things. So there's a playlist for Linux fundamental course in that, so you can have a look, and it will kind of give you a good base if you are new to the world of Linux and Unix or the command line. So the agenda for today is what is Apache NiFi, what problems it solves, NiFi architecture, and some of the features, right? So these things we will look at. As I said, it's a very vast topic, but we'll be touching upon some of the very fundamental, right? So this is the Apache NiFi canvas. I have set up an Apache NiFi cluster, but we will be looking at only the fundamentals, as I said, right? So common use cases, um, anyone, right, who is talking about data, right, whether it's big data, data warehouse, data lake, or any of the systems, right? So you need to bring data into the system. So first thing is you need to extract or ingest data. It could be from databases, which could be your traditional RDBMS or NoSQL databases. You can ingest from streaming apps, systems, let's say a Kafka or RabbitMQ or any kind of streaming systems, or you can call any of the REST API and API gateways, or let's say the common one nowadays is IoTs, right? So you may have devices deployed in a lot of places. It could be, let's say, an example, an oil well, where you are monitoring temperature, pressure, humidity, a lot of other parameters. So you will already have some devices there which are taking care of it. You just install an edge device which will have your agent running. Agent could be your NiFi agent, which is a lightweight uh, version of NiFi, which is available both in C++ and Java, which you can install on an ASIC, which is application specific ICs, and it can send data to your systems. Also, you can use it for file format conversion, let's say from text to JSON or text to let's say ORC or Parquet, which is optimized storage format. And in addition to that, definitely like monitoring and alerting, right? So you can do a lot of REST API calls as well to the other systems, and do operations based on the status code returned by APIs, and make decisions on monitoring and alerting, right? So although we will not be touching upon all those things today, but I will be giving you kind of a context of what it is, and look touch upon some of the points we have mentioned here. Let's say bringing your data from a database, which could be MySQL, and then writing it to different systems, right? So that's we will be looking into. Okay, so as I mentioned, right, so the uh, scope for setting up Hadoop cluster or a NiFi cluster, we can look at in some other session. So let's look at what Apache NiFi is, right? So Apache NiFi is an integrated data logistic platform for automating the movement of data between disparate or discrete systems, right? So let's say moving data from a system A to system B. And the beauty about NiFi is it provides you a web UI with a drag and drop boxes to control the flow of data, right? So you can control, okay, where the data is fetched from, where it is written, and you can apply a lot of controls like the rate of flow, whether data should be filtered or some field needs to be added or not, right? A lot of things we can do. So Apache NiFi is a project which was contributed by NSA to Apache Hadoop, sorry, to Apache NiFi, the Apache project, and then Hortonworks has been a major contributor to it, and most of this has been provided free under the packaging called HDF, right, which is Hortonworks Data Platform. But after the merger with Cloudera last year, 2019, mid of 2019, it has been rebranded as CDF, which is Cloudera Data Flow, and anything released after that has been behind a paywall, right? Means you need to have a license to use it. But anything prior to that you can use it, right? So we'll be looking at what problem it solves. So as I said, you can ingest from multiple sources without writing code, right? So that's a very quicker way of writing your data, writing your data pipelines. So you can ingest from multiple sources. Let's say it could be your database. You can do ETL, you can do light load data processing. So when I say light data processing, means don't think it as a replacement for Spark or any MapReduce, although or Hive, Thales, those kind of operations. Although NiFi can kind of orchestrate that, and NiFi can say, okay, write data to uh, a knife to a location on HDFS which has, let's say, a Hive layer on top of it, or insert to HBase, and you can do a computation outside it. But NiFi is not for computation, right? So you can do decision routing, you can do filtering, you can do replace text, right, light processing, or regular expressions, but you cannot do use it as a core processing engine. So this is a very important thing to keep in mind. And obviously you can control it using the REST APIs. You can start, stop processes. You can monitor the health, and you can also control or schedule it using any of the tools outside of NiFi. But NiFi itself gives you a lot of capabilities of executing the ingestion flows, right? So which will be, I will be giving you an example. So first let's look at an architecture, like how similar to Hadoop client server architecture, where we can have a master node and the worker nodes, and also we can have multiple nodes, right, rather than having a single node. So similarly in NiFi, we can have a NiFi instance, a single instance, or multiple instances which can work together in a cluster. So on a single instance, this representation is from a single instance of NiFi, which runs on OS with a host, host with an OS on it, and it is running inside a JVM, right? So when we say JVM, right, it's a Java based system. So it has a web server. So this is one where you interact with, right? So the web UI page which I showed you at the beginning, right? So this is the page it listens on port number 9090. So you go to web server, and using web server you can define the flows, the controls, and what actions it should do. And next is the flow controller, which is the brain of NiFi, which decides, okay, what kind of a processor, what activities it does, and all those kind of things. And then there are repositories, right? The flow file and a lot of other repositories as well, right? Content repository, the provenance repository, which we'll be looking into detail as we go along. I will explain you what they mean, right? At the moment they might not be very clear, but flow file repository, what it does is this will be a repository which will be storing the state of the flow, right? Where I was when I was reading something. Let's say you're ingesting data, and okay, where I was in that state when I was reading data, right? It does state checks. Similarly, there's a content repository which talks about the contents of that flow, right? What is a flow? It or flow file? It will be clear in a minute. And similarly, provenance, right? So it will be talking about where the data came from. Let's say I may be consuming from MySQL, writing to Kafka, and Kafka writing to some other downstream system, and I can go and look into provenance and see, okay, what is the flow data followed, right? So that's what it keeps track of, right? All those repositories are stored on a disk. So again, it's important that the disk where it's storing has a decent performance, right? So all those things from a performance perspective, the troubleshooting perspective will be in a cluster part, but here we will look at directly of a demo. So let's look at a demo of NiFi. I already have an Apache system running, right, which is with the Ambari, right. I'm using a Hortonworks distribution which is freely available, right, so you can download, use it. So I'm running bare minimal, Zookeeper, Kafka, NiFi. So you can see if I go to NiFi node port 9090, I get this canvas, right? This is called a canvas on which you can drag drop, and it will let you configure your flows and controls. So there are so many parts to it, but we will look at some of them one by one. So there is a concept called processor group. So I can give it a name, let's say meetup underscore demo. So what is this? This is a logical grouping, right? So rather than kind of cluttering the canvas, I can make small groupings, and within that grouping I can have multiple things. I can input output ports, I can have processors, right? All those kind of things, right? So let me just scroll back. So we have a meetup demo, right, which is, as I said, it's more of an organizational unit. Again, it has technical significance as well. We can have a remote group ports and all those kind of things, but for the sake of this discussion, just think it as a more of an organizational unit to organizing things. So I drag a processor. I have around 301 processors in this version, and every version you see few processors being added. And if you are not happy, you can write your own processor. You can create an R, which is a NiFi archive, and do it, right? So here let's add a processor which I'm calling query database table. So if you look into the processor, you will see a name, right? So I can change whatever name I want. You will see the ID, the type remains constant because that's how it will be calling the classes. You can look at that nar which I was mentioning. So it's NiFi archive, how you have jar, Java archive. Similarly, you can create nar and keep it in the libraries, and it will load it. So I'm giving some name to it. Then it looks, we look at other things. For example, yield means how long this processor will run, 1 second, 2 second, 5 second, right? So it is defining what will be the yield, how long that processor runs. Scheduling, I can have a time driven scheduling. I can say continuously run at 1 minute, 2 minute, 5 minutes, right, intervals. Or I can also use a cron tab, right? So this cron tab is slightly different than the Linux cron tab. This is more of a quartz cron tab, which has 7 fields rather than having normal 5 fields, right? So again different discussion. We will maybe look in the future session. So right, so I'm just using the default time driven. I will be saying, okay, some time, let's say every 2 seconds or every 3 seconds it should run. And then you have the execution where it should run, right? So here you can see it has primary node and all nodes. All node is disabled, right? So there will be processors which will run on all nodes. Like let's say, as I said, in a NiFi cluster you can have multiple nodes. So there will be some processor which can run on all nodes. Some will be running only on primary nodes, right? So we will see why that is later on. Mainly it would be something like, let's say I cannot have a table being ingested by multiple nodes because there will be duplication of data, right? So that's why this processor is running on only one node. So now we define the strings, a database connection pooling service, right? So which will be kind of setting up your controller service. What does controller service means? I define a connection string which where I will be defining, okay, what is the driver it will be using, what node it needs to connect to, what will be the class it will be calling, right? So this is what I'm defining. We go and configure controller settings. In this one, let's say it's asking for database connection URL. So what we'll be giving here is, you will be giving the MySQL connection string, which will be like your JDBC colon MySQL colon and that connection string, right? Your node name, port, and your database, right? So that's what I'm specifying. I'm using a MySQL DB with a database test, and I'm specifying also a driver class and the driver location, right? So let me show you driver location from one of my nodes. Let me just pull in the Linux node terminal. So as you can see, I've connected to one of my Linux machines, and I am showing you the path: user share Java MySQL connector, right? So this is from a package called MySQL connector -java, MySQL connector -java, so which is shipped by default with Red Hat or CentOS. So I'm just giving the path of that jar, which it will be using as a client to connect to the MySQL, right? And I will also be providing, as I said, the username and password, right? I'm using root here. This is not a production system, so root is fine. Usually we will not be using root to connect. We will be having a dedicated users, and then I need to give a database driver class name, right? Which would be something like com.mysql dot driver, right? jdbc dot driver, right? com dot mysql. So this is a class which it will be using to call from that library, right? Which we are giving a path of that jar, right? So I'm saying com dot mysql dot jdbc dot driver, right? So this is a class I'm calling. I'm saying okay. So this is the name. All settings are fine. We say apply, and then I say enable. So I have enabled that, and once you see it got enabled, there will be a tick on it, and now this is more of a controller, right? So it has got enabled. I close this one, then I go back to the processor, I click on configure, and I go to generic. Here you can select MySQL, you can select the table name, the table you want to connect to. So database was test, which I have given in that controller setting. Here I am giving the table name employee, and I'm giving the primary key, right? I'm giving the primary key for the table, from the table. It's not mandatory to give here, but we are trying to do kind of a CDC, change data capture. Let me show you the table first, how the table looks. So when we are doing a CDC, right, so it should keep a track what has changed from the last time, right? So that's why I am giving it a column which is unique, primary, and kind of changing. In auto incremental I've used here, right? So there could be different cases which we look into what happens when a data is updated rather than simply added, maybe in the future session. So I'm just giving you a simple demo here. So I have a table, let's say select star from employee. It has 6 rows, you can see here. So you can see it has a primary column which is employee underscore ID. Okay, I will correct it. It's employee underscore ID, not employee hyphen ID, right? So I'm correcting that. So I'm saying underscore ID, I save it, okay. And then other are like what is your wait time, how many retries, all those kind of things, which is from a performance perspective. We will look into all this maybe in the future sessions. So each of the processor which we use, right, has maybe an IO bound, it may be a CPU bound, right, it could be a memory bound processor, right. So all those are different discussions. So once we have specified that, I say okay, the maximum ID I have specified, as I said. So this is the primary key which we are specifying, and this is a unique in the table, so I am saying processor to monitor it, right. It will be keeping a track of that, so it will be clear when we run this flow. Let's pull one more processor. I say update attribute, right. So let's look into it. I do a connection flow. I say success. When MySQL is DB processor is successful, it should send that data to the next processor, which is update attribute, right. And update attribute, I'm saying success, I'm terminating to itself, right. When a success happens for that update attribute, we are not sending it anywhere, we are saying okay, that's the endpoint, success, right. You go there, right. Similarly, it has schedule and all. Now here if you look, right, I can have execution on all nodes or just on the primary node, right. So in a node, this processor can execute on all nodes or on the primary node. I can select that, right. But in the old other processor, if you remember the MySQL one, it only showed you the primary processor, right. Otherwise it will result in the duplication. So this is what I mean. Let me show you there. So here it will only show you primary, not all nodes, right. Because if I run it on all nodes, or let's say if this processor was built to run from all nodes, then it will have duplication of records coming in, all nodes pulling in from a table. That's why it executes only on one of the primary nodes. So I will show you later on what is primary node. There's a concept of election which happens, and one node will be dedicated as a primary in a NiFi cluster, and that is designated as a primary node. So you can see from the processor itself when whether that processor is running on a primary node or not, right. So there's a there will be a P sign coming on top of it, you can see there. So it is saying that this processor will run only on the primary node. So we have I say start here. So the moment I said start, you can see it's saying 2 active threads, and you can see some data has flown through. You can see the bytes, you can see a queue. I right click and say list queue. I go into the details, and you can see here these are the flow file details. It has some metadata and it has some attributes. Attributes will be, let's say, the max employee ID, the table it talked to, right, the type, and you can see it's talking about 6 rows it has, right. It has max employee ID is 6, and it has 6 rows, right. So that's what it is telling you there in that attribute field NiFi, right. So it's all fetching automatically, right. So imagine you have to write a code manually, and you have to take care of all those things, where I was reading, what is the max value and all. So it will be a lot of work. So now I go to view. Now I'm looking into the contents of the flow file, right. So this is coming in a JSON format, all the rows I had in a table. So we look into what is a flow file, right. Flow file is a combination of metadata and the data, right. So processor we know, right. Processor is what we dragged, right. So this is a processor, MySQL DB is a processor, update attribute is a processor, right. And the connection between them is the flow, right. It's saying okay, you are going in this direction from MySQL to update attribute. This is the direction of flow. You consume data, write it there, right. This is how we are defining a flow. Flow file is your original data with your metadata, right. So the data which is coming from the MySQL processor in NiFi, that data which is pulled in is represented as a flow file. You can see here flow file details. So it has some attributes, some metadata, right? Attributes to associated with it, and the actual data as we saw, right? Actual data. So this is your flow file which has content and attributes. And then we have back pressure. So back pressure is something to control the influx of data, the flow of data. For example, there could be various kind of processes, right? One is could be simply, let's say in this case, MySQL DB, which is pulling data from a table, and table can have one row or 10,000 rows or 100,000 rows, and the processor which is sitting next to it may be doing some regex, maybe doing some replace, update attribute. So it might be taking a little bit time, and the data which is being pushed is pushed at a higher rate. So what you can do a back pressure and tell, okay, slow down to the other processor. So that's the concept of back pressure. So that back pressure is set up on the flow, right? The connection between two processors. So if you look here, the queue which we have done, I right click here on this one, and if I go into view configuration, you will see there will be back pressure values, right? Number of objects and the size, I can control it, right? And this concept of load balancers also. Here it is coming disabled because the flows are running, it has some data in it. Once I stop and clear it, I can change those configuration, right? So let's look into it, right? So as I said, this is disabled. Once this is cleared, it will I can change those parameters, right? So all these attributes are there. So these all will be your attributes. So I can go to source where it is coming from. I can go to status history. I can look into what kind of data is flowing through it. I can look at bytes or over a different time windows, right? What is the data flowing? And also I can empty the queue, means I can send this data to null, dev null, right? Which I'm not doing at the moment. Similarly, I can do a view state, right? As I told you, so that MySQL processor is consuming data. Now it is keeping a track, it's keeping a state, how much I have read. It has read, I have read 6 values, 6 rows. So it's keeping a track, right? So what does it mean? Even if I stop and start it back, it will be there. So this is flow file repository where it is keeping a track. So now let's add some field here. Add attribute. So this attribute you saw, right? There was no attribute where it talks about timestamp. I write an timestamp. I use expression language. It uses NiFi has an expression language which is quite powerful. You can use regex, a lot of functions to insert, manipulate data. So I'm calling now system time, which will be appending whatever your time on the system where this processor is running, and it will append as an attribute to that flow file. And later on you can leverage that attribute to some field, right? Maybe you are writing a Hive table and you want to know what time this particular data hit my NiFi flow or when it was ingested, like example. Let's write one more attribute. Let's say update record. I'm adding a new processor. So update attribute is just updating the attribute. Update record is actually updating the content of the file, right? Updating the content of the file. So if I go here, configure, I'm saying success. I'm terminating to itself. I'm just taking another one and I'm saying okay. I'm saying failure, send to some funnel, some right where it will funnel and maybe go to another systems, or just I will be clearing it end of the day. So I will be just specifying record reader and record writer. So I'm just starting those services, means enabling it. Record reader, record writer, and this is an Avro record reader and Avro record writer. Because you saw the file input which is coming in, it's an Avro binary and formatted looks like a JSON one in there. And I activated, my controllers are activated, and now you can see here, if you hover over it, it will tell you what it is asking you to do, right? It's asking you to add an attribute there, right? So which we will see in a minute, right? So I will say apply. Now I will start this particular processor. And now you will see the data which is coming in from processor has come in there, right? So now you can see, I go to attribute and you can see that value has been added. Okay, so I made a mistake. I've given a round bracket instead of a curly brace there, so that's why I did not evaluate. Yeah, we'll change that. So you can see that timestamp field will be added there, right? So I will correct it once we stop that. So now you come here and you go to properties and you say here literal value or a path value. You can do a lot of things. Again, as I said, there are a lot of details here, but let's keep things simple. So here I would be here, what we will be doing is, in the attribute update attribute, what we have done is we have updated the attributes, not the file. If you look at the contents of the file, nothing has changed. It's all same, whatever is come in, right? Nothing has changed there. But what if I want to change the contents of the flow file? I want to add some field inside that, right? So then I have to use update record, right, rather than update attribute. So what I do, I add, and again you have to specify it as / if you want to update a record, right? So it's a convention, you will get used to it. So this field will be added to that, and I will be saying dollar curly braces now function, and this will be added to the flow file content itself, right? And now I say that one, let me start it, and you will see. So in this case we have for the update record, we have a success terminated to itself, means it is not sending anywhere. So we will not see any data coming out what has happened, because it itself is the success. So that is the sync itself, right? So data has not gone anywhere. So, and it was not a failure, so it has not gone to funnel. So what we can do is, let's write something, another processor. I say put file. So I say put file connected. I say on success go to put file, and on failure we are already saying is going to the funnel. So put file, we don't need to look into the details of that. You can write a file to any file system other than HDFS and all, because put file will be writing to a non-HDFS file system. So here you can see it is talking about 6 records it has fetched, right? So I stop it. Even if I start it back, it will not go and fetch all records again, because it knows the state where I was, right? Because it's maintaining a state in that state repository which I showed you. But let's add one more record here. Right, so let me add some record, and I will just change some other fields, and let me just give meetup here, and just add that record. Now you can see I have 7 entries. And now what will happen is, you see that immediately it has run through, right? It has come here, and now you open it and you look into it. It would have fetched just one row which has changed, right? Only just one row, last one, right? All others were already ingested. So processor knows that. So it's doing CDC, but it's doing a CDC on new add, right? There will be CDC on update as well. We'll see that later. So now let me just stop this one and empty this queue. Empty means I'm just flushing it to dev null, just discarding it. And what I do, I stop with this one, and we will clear the state of that processor. Right, so it will take some time for it to, right? If you see, I cannot click it because although I have given a stop processor, it takes some time for the processor to stop. Right, if you see here, I have stopped it. And now you go here and you can see now I can clear state. I cleared the state, right? Now I start it again. So now this processor doesn't know where it was because we have cleared the state. I start it, it will fetch all the records, means all the rows, whatever it would be, right? So by default we are not controlling how many rows it should fetch because we already had very few rows, 7 or 8, right? So see, you can see it's coming here, but we can do that if we want. So you go here, you look here, and you look into the data, you go to format it, and now you can see all data has come in again, the 7 rows, right? It fetched everything, and now it will be coming here. So this is stopped. Let me just correct it, and I will change this to curly brace, and you can see that function changing the color, so you will know it's a varied function. And I start this one, and now let it come here. Now what we're doing is we are adding an attribute which was not part of the original flow. So it's not added to the content of the file, it's just added as an attribute. So you'll see that processor will run. Yeah, see your data has gone through and it has come to the second flow, right? I look at that one and I go to attributes. You can see that timestamp has come in, and timestamp can be various format. I can write whatever expression I write there or expressive language I write there, and you can see formatted. So nothing has been added to the content, only attribute has been added till now. Now let's go start this one, and now you will see the contents would have been modified. Now we are saying add to the content also, not just to the attribute. We are using update record, and it will look into the flow file and add an entry to each record. Means row is a record, so it will look at each of those rows each record, and add that timestamp to it because of update record processor. So it has come here. Let's look into it. Open it. I say formatted, and you can see a timestamp has been added to each of the rows, right? So this is what it is doing, right? So this is very powerful tool, and it's not just this simple thing. I can write to various places. I can do routing, I can do replace text, I can do regular expressions, I can write optimized files, right? It will this processor which creates an ORC files. I can write Avro files, right? Parquet files, a lot of things it can do. So now let's look at back pressure. So I will stop these ones, and I'll just if I click here, it takes some time for it to stop, and you can see it's still coming as view configuration and it's read only. I can refresh it quickly over there from the browser, and now you will see it has become configure instead of view. Means now it has gone on from read only to read write mode, right? I can make changes. Now I can change back pressure in terms of number of objects. I can change in terms of size, right? I can say size threshold. I can change the load balancer, right? I can say round robin, single node, right? Partition by attribute, and I can also change the order, means first in first out, last in first out, and so many other things, right? How the data should be flowing in. So now So let's look at some of the other settings, right? So I go to cluster. So this is telling me how many nodes I have. So here you can see this is a primary node. It's telling me I'm the primary node. Then it's telling you about settings, right? For example, in terms of system memory, JVM usage, right? Heap usage, right? Then you're telling you how much space you have. As I said, the storage, the repositories will be on disk, and Java version. This is my uh, kernel version, right? If I go and do a uname on my system, you can see that that would be my kernel version, right? Uname hyphen a or r hyphen r I do, right? So I can see here that's the version which is it is showing up there. Again, a lot of details. It's a very powerful tool, and I can look into data provenance. Means I can look into how the data flowed into. You can look into that. You can see download, content download, right? Attribute modified, all those things, right? As a holistic view. I can go to a processor also, and I can look into view data governance, right? I can see what is the path data took to reach here, right? I can look into the history, what it was, attributes, the metadata, right? I can look into view. I can replay it, right? I can let's say if I click on view, I can see okay what was the history which went through, right? I can also click here and look at the lineage. See how beautiful the graph comes. It tells you how the data flowed through. It's telling you the lineage, and all this lineage and provenance, right? You can export it to an external source as well, right? It doesn't mean that you have to keep it within a NiFi. There's a REST API is available. You can keep it outside as well, and you can save templates. I can select all. I can say give any name, give any description. This is a test template, and I save it. And now you can see I can also I can create, I can load that template back. Right here you can see, here you have, if I drag it down, you will see templates here. I can just use that template, and what I can do is I can also download this template and later load it somewhere, right? So I go to templates, I can download those templates which I just created, right? And it will save it, right? So you can load it back. Right? Bulletin board, it tells you the messages what it gave in from the last stage, right? And other things like controller settings, right? We have configured a lot of controllers, so it talks about all those controllers. So we have looked at all these components, right? Processor, flow file, back pressure, process group, right? All those things we have looked at, and there's so many other things which it can do, which is itself it's a very extensive course in NiFi, and if somebody is interested, feel free to reach out to me. Although I said I don't do full-fledged trainings, but if somebody is looking for some mentoring sessions or something, most welcome, right? So we have touched upon some of the features like buffering. I demonstrate how it buffers when you stop a corresponding processor. It has flow optimization, right? Or it has you can have a security in terms of authentication, authorization, right? And also it allows you to do recovery, replay of individual files, as we discussed, right? You can have encryption, secure channel communication, and all that. right? So all that it enables you to do that, right? So yeah, any questions here? Yeah, so I had one question, right? The difference between Kafka and NiFi, right? So I said NiFi is more of a flow orchestration system, right? It talks about okay how the data moves across, but it's not actually storing data. Whereas Kafka is more of a queuing system, right? It differs slightly from the messaging system. It's a pub/sub model where you push data from one side to a topic and consume from the other side, and there's a retention which is configurable. You can store data in it, and whereas NiFi, it's more of building the flows, right? What happens to the data, where it goes, and all those kind of things, rather than storage system, right? So it's not a queuing system. It's kind of bringing in all things together, and it can talk to Kafka. It can say send data to Kafka, consume from Kafka, all those kind of, right? It's giving you a controls. Okay, I can also align it, right? Let's align it horizontally, vertically by selecting all. I can just say right click. I can select on a processor. I can say write to a particular location, all those kind of things, right? Again, it's a very powerful system, right? I can say put HDFS, put HBase, right? HBase cell, right? A lot of things you can do here. You can do grok filters, you can do jolt processors, right? All those kind of things. So thanks very much for attending this. So as I said, right, feel free to reach out to me with any questions you have. So it necessarily doesn't mean it should be related to training, but it can be anything, right? If you have any questions, any technical issues, need guidance, need help with anything, feel free to reach out to me. You can go across my GitHub, and you will get an idea about what is my background, and feel free to reach out on any of the questions you have there, right? So it's all good, right? And I will try to do these sessions more regularly in meetups, and hope to meet you guys more often. At least maybe we'll try to do at least a month, or we'll see at least two, or we'll say two times a quarter or something. We'll try to do that, right? So because of my busy schedule, I couldn't find time, and especially because of COVID, right? All our schedule